Hello everyone and welcome to a new HyperWorks tutorial. To begin, we will open the model by going into File, Open, HyperMesh Model, and browsing to the file associated with this exercise. Display the part browser and review the parts and the part assemblies to understand the model structure. Hide all parts of the loft assembly except for the GA fuselage. This component contains the section of the fuselage that we will be working with. GA aircraft lines assembly contains the lines that we will use to create the stringers and frames of the fuselage. These lines have metadata attached to them that will assist in performing this task. To accomplish this, the first step we need to do is isolate the lines and verify that the quality is adequate. There are some discontinuous areas where the lines either need to be extended or need to be trimmed. Go to the Geometry ribbon in the Create group and select Combine/Extend Lines. In the guide bar, be sure that the drop-down menu is set to Extend. Select the line that we want to extend. Be sure that the Choose Target checkbox is selected and the target is set to lines. With the target drop-down menu selected, select the destination we want the lines to extend to. Follow the same procedure for the second line. Lines can be trimmed using the Split Lines tool. From the target drop-down menu, select the two lines that we want to trim. Activate the Tool button and select the two lines where we want to perform the trim. Next, press Split. The overlapping line portions are divided into separate lines, and we can delete them by changing our selection to lines, selecting them, and pressing Delete. Now that we have sufficient line quality, we need to check the fuselage surface. On the surface of the fuselage, several edges are present. These edges are indicated by the solid black lines on the surface of the fuselage. In the Geometry ribbon in the Edit group, select Stitch. Suppress several of these edges on the fuselage. Now that the lines and the fuselage have been prepared, we are now ready to imprint our lines into the fuselage surface. In the Geometry ribbon in the Edit group, go to Imprint. Make sure that the source box is set to lines. Isolate the stringer and frame lines in the GA aircraft lines assembly and drag to select all of them. Then select the target box and select the surface we want to imprint on. As you can see, the highlighted section of the fuselage is considered one surface since we suppressed its edges. The lines have now been imprinted onto the fuselage surface as edges. At this time, we can fix any discontinuities in the edges by using the Split Interactive tool. Review the model and patch edges where needed. stitch and remove unnecessary fixed points. Save your model before proceeding with the mesh generation. Optionally, you can cancel the save and instead open up the cleaned up version that is provided. Now, create a 2D shell mesh for the section using General 2D Mesh. Select the surfaces highlighted here and use an element size of 40. The Density tool can be used to edit the density of the mesh and improve its quality. To uniformly change the densities of the frames and stringers, open the Options of the Density tool, Advanced, Link Opposite Edges, Set to Uniform Distribution. With this, changing the density of one frame will change the densities of the same region on the remaining frames. Use a value of 4. This same step can be performed for the stringers of the fuselage. For this, use a value of 16. Another method of improving mesh quality would be to create a fuselage mesh using the panel mesh. This tool will generate a mesh without the use of triad elements and will automatically apply a uniform density across the party. Exit from General 2D Mesh tool, change Entity Selector to Elements, and select all of the elements displayed and delete them. Choose Panel Mesh from the drop-down menu under General 2D Mesh. Select the same surfaces as before, define element size of 40, and press Mesh. To add thickness to this mesh, click on the GA fuselage component where the mesh is located. Right-click on Property and hit Create, and add 2 as the value to the thickness section. Close and review the mesh just created. Changing the viewing settings can help better visualize the new mesh, which is made entirely with quad elements. Save your model before proceeding, or open the provided model for the next step. Next, go to the Assembly ribbon under Organize Group, and under Renumber, select Spatial Renumber. Renumbering the element IDs of a 2D shell mesh can help further its organization. Establishing a nomenclature for the element IDs will aid in locating individual elements for further analysis. Once the tool is open, change the setting to Adjacent Renumbering, change the selection type to Elements, and in the options, check the box for Show IDs on selection. We can now select elements which will show all the current element IDs. As you can see, the current element IDs do not follow an easily interpreted pattern, making quick element location difficult. To establish a renumbering algorithm, click on Options from the guide bar. For the first element, choose 3680, which will be the starting element of our renumbering algorithm. This element should be found near the bottom of the model. Upon selection, the current ID of this element will appear in brackets in the Start button. Following this, select the primary direction that our renumbering algorithm will follow. For this, select the element 3859, which follows the longitudinal direction of the fuselage. Finally, establish a secondary direction. For this, select the adjacent element in the positive y direction, which is element 1059. To add increment in the secondary direction, click the Continuous Increment button in the micro dialog, and then add an increment of 100 in the increment window. Since our mesh is two-dimensional, we will not need to establish a tertiary direction. When we press Go, we can see that beginning with our start element, the element IDs are now numbered from 1 to 59 as they extend along the longitudinal direction of the fuselage. Additionally, the row of elements adjacent to this begins from 101 to 159. This pattern continues for the whole fuselage, allowing for easier location of individual elements. Now, you can save the model to finish.